Next up, I would like to draw the Lewis structures for NO2Cl and NO3Cl. So let's start with this one, and then we'll get to this one right after. So as usual, count your valence electrons. I have 5 from the nitrogen, 2 by 6 because of the oxygen, plus 7. That is going to give me 5 plus 12 plus 7, and that is going to give me 24 electrons. And so in my structure, I will surround the nitrogen with the 2 oxygens and then the chlorine. I chose nitrogen as my central atom because it can make the most bonds. Number of bonds is just 8 minus the valence electrons for whatever atom you're looking at. And so for nitrogen, that is going to be 3 bonds. Oxygen, that is going to be 2 bonds. Chlorine, this is going to be 1. And this would just be the optimal number of bonds for that atom. So the number of bonds that would minimize its formal charge. Next up, I'm going to put valence electrons around each of them to fill in their octets. See if I have anything left for my central atom. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I do not have, sorry, let me just ensure. Everything is okay here. Okay, and then, so since all of my valence electrons are not taken care of, because I do have 24 electrons here, let's see about the formal charge. Okay, so for nitrogen, that is going to be 5, minus it only has 3 electrons in each of these bonding pairs, so it's going to have a charge of 2+. On the oxygens, each of them, it is going to be 6 minus 1, so -1. And lastly, on the chlorine, it is going to be 7 minus 7, so that's going to give us 0. And so, what this means is that I have a minus and a +2 here. This isn't the optimal structure for NO2Cl because of all of these formal charges. Optimally, I'd like just one minus charge somewhere. And additionally, the net formal charges aren't adding up the way that they're supposed to. They're supposed to add up to 0, and these ones add up to a -1. And so there's something wrong with the way that we've chosen to put electrons in bonding pairs or electron pairs, despite the fact that the valence electrons are correct. And so now let's go about fixing that by replacing certain lone pairs with bonding pairs. And so ideally, we'd like to leave the chlorine alone. We already found that it has a formal charge of 0. And so now let's start messing around with the lone pairs on these 2 oxygens to see what would minimize those 2. And so we can start by just placing a double bond here, and that would get rid of 2 electrons. And so now I have this. Nitrogen is happy, it has a full octet, and so do the rest. So the structure is obviously better than what we had before. Just ensure that all of your electrons still add up. 10, 12, 14, 16, 18, 20, 22, 24. Yes, they do. And then now we go about counting the formal charge again. And so on the oxygens, I'll have to label them now since they're different. So on oxygen 1, it's going to be 6 minus 4 minus 2, giving us a 0, so it's happy. On the nitrogen, it is going to be 5 minus the 4 electrons that it has in a bonding pair, so it's going to be +1. On the chlorine, we already found that it's going to be 7 minus 7, 0. We didn't change anything about it. And on the second oxygen, we will get 6 minus 1. And so we're going to get -1. And so we've seen that the formal charges have come down, which is what we wanted. And additionally, they're adding up to the correct value. They're supposed to add up to a 0. We have a 0. So this is going to be a valid Lewis structure. Next up, we need to answer the question of, sorry, let's just put all of those charges in. If there is another Lewis structure for this compound that still minimizes the formal charges and counts all of the valence electrons, but I change the configuration of lone pairs and bonding pairs in some manner. And there actually is. For those who would have wondered why I chose this as the double bond, I could have as easily just decided to make this one the double bond, and that's actually going to be our resonance structure. And so now this nitrogen will be positive, this one will have a charge of 0, and this one will have a negative charge. And so these are going to be our two structures for NO2Cl. Next up, I have NO3Cl. And so again, count your valence electrons. I have 5 plus 6 into 3 plus 7, which is 5 plus 18 plus 7. And that is going to give me 12 plus 18. So I have 30 electrons to mess around with. So now let's put again nitrogen as my central. I'm going to connect again the two oxygens. And let's say I start with the general structure of this. Okay, fill in all of my octets. And see if I got the 30. So I have 6 into 4 plus 8, and that is going to give me 24 plus 8, which is 32. So I have too many electrons this way, and that would make it tempting to start making double bonds, but I need to account for the fact that nitrogen can't have an expanded octet, and that's because it's only in period 2. Period 2 is nowhere near the D group, and so nitrogen doesn't have access to the ability to have d orbitals that would help make space for all of these extra electrons we're giving it by giving it an expanded octet. So it makes the most sense to move this chlorine, and instead of attaching it to nitrogen, attach it to one of the oxygens. You can pick any of them, it does not really matter which one. And so let's attach it to this one. Again, fill in our octets as we did before. See if we have any electrons left over. So we have our 30 electrons if we draw it this way, right? So next up, let's check our formal charges as we did before. So let's go about checking our formal charges. And so on these two oxygens have the same electronic configuration. This one has a different one. So on the first oxygens, it'll be 6 minus 6 minus 1. And so that's going to give us a -1. On the second oxygen, it's going to be 6 minus 4 minus 2, yielding 0. On the chlorine, it is going to be 7 minus 6 minus 1, yielding 0. And lastly, on our nitrogen, it is going to be 5 minus 3, yielding +2. So again, we're running into the same issue of A, the net formal charge is not equal to what it's supposed to be, which is 0. And additionally, we have not minimized the formal charges. This is usually an indication that you need to go back to the drawing board and adjust it with double bonds, or remove any double bonds and replace them with lone pairs. And so let's go about doing that. And so we found that this oxygen and this chlorine are already happy with their formal charges. And so it makes the most sense to not change them with any double bonds, because that would mess up the formal charge even more. And instead, let's put in a double bond with one of these oxygens. And so you can just pick any one of them. Make sure your electrons still add up the way that they're supposed to. So I will have 4 by 2 plus 6 by 2. Well, yes, they do still add up. I do still have my 30 valence electrons. And then next up, I want to check my formal charges again. So these two oxygens now have the same electron configuration, so let's label them. So the oxygen ones are going to be 6 minus 4 minus 2, yielding 0. Chlorine is going to remain 7 minus 7, yielding 0. On the nitrogen, it is now 5 minus the 4 electrons it has in bonding pairs, yielding +1. And on the last oxygen, it is going to be 6 minus 6 minus 1, yielding -1. And so I can see that the net formal charge is 0, as it's supposed to be. And additionally, I've minimized my formal charges. And so this is going to be a valid Lewis structure, since everything is now taken care of. Now again, I need to answer the question of, are there any resonance structures? So is there any way I can change one pair of electrons in a double bond like this back into a lone pair, or move a lone pair into a double bond? And I see that I can. And usually this is how you notate your resonance structures. So you'd say I have 2 electrons coming there, and I have 2 electrons now entering here. And so my second structure is going to look like this instead. And so the net formal charges haven't changed. I've simply moved the negative charge that was here onto this one, so that this one now has a neutral charge. The nitrogen is still positive, it still has the same 4 bonds that it had before. Let me just space these out a little bit. And then to just show that the resonances, I just have that sign in between them. It would usually be horizontally, not vertically. I just wrote it this way because that's how I drew it out on the page. And that is going to be it for this question.